Hi everyone, welcome again. So in this particular series or in this particular video, what I'm thinking to cover all the Spark related interview related questions. I'm thinking to make at least 5 to 10 videos on Spark interview series. Every video will be specific to different components. For example, let's say this video will be about general Spark questions, or we can cover, and I will be covering joins as well. In the next video we can cover performance tuning. In the next video we can cover adaptive query execution. In different videos we can cover different stuff. What you guys can do, if you guys want anything specific, please do comment in the comment section. Please do subscribe the channel, because what I'm seeing that people are watching the video, they're liking it, but they're not subscribing it. Not sure where. So basically, subscription is free for you. It don't cost anything from you, but it means a lot to us, right? For this YouTube creators. So do subscribe. Anyways, so when we start, when the interview starts, right, related to Spark or any data engineering thing, so after your introduction, interviewer generally asks, when they jump to Spark, they will be asking what actually is Apache Spark. So you need to answer it in such a way that Apache Spark is an open source distributed computing system used for big data processing analytics. It provides high-level API for processing large amount of data in parallel across cluster of computers. Sparks offer a faster and more flexible alternative to traditional big data processing frameworks such as Hadoop and MapReduce. See, since you have used your Hadoop and MapReduce, the next question might be related to Hadoop and MapReduce. But let's go ahead. So Spark also provides API in Scala, Java, Python and R, making it accessible to a wider range of developers and data scientists. It also includes libraries for SQL, machine learning, graph processing, stream processing, making it a versatile tool for various data processing tasks. Spark is designed to be highly scalable, efficient, fault tolerant, making it a popular choice for large-scale data processing in industries such as finance, healthcare, and technology. Additionally, Spark has a unique feature called in-memory computing, which allows it to store intermediate data in memory, specifically improving the speed of iterative algorithms. This makes Spark well suited for iterative machine learning algorithms and interactive data exploration. Spark can be run on a standalone cluster, on cloud infrastructure, or in Hadoop cluster using Yarn or Mesos as a cluster manager. It has large and active open source community and continually develops and maintain the platform, adding new features. See, basically, if you just cover the first these two paragraphs, you are more than good. But the most important bit, when people or interviewer ask about a Spark, you need to cover 2 or 3 things. First, it is distributed computing, right? The second, it is in-memory computing, right? So, and different APIs. So this is how you need to explain what Apache Spark is. Now, since we have talked about traditional big data processing frameworks such as Hadoop, MapReduce, the next question might be related to what exactly is Hadoop MapReduce and how it is different from Spark, right? So when we talk about Spark versus Hadoop, you need to cover it into multiple ways. So let's start with architecture. Hadoop is based on batch processing model where data is processed in large chunks, while Spark is designed for both batch and real-time processing, offering low latency and high throughput. When we talk about data processing, Hadoop MapReduce processes data in 2-step MapReduce process, while Spark provides more flexible and high-level API data for data processing, including support for SQL, machine learning, graph processing, and stream processing. Now, the third point is important. It's called in-memory computing. Spark uses in-memory computing allowing it to store intermediate data in memory, significantly improving the speed of iterative algorithms, right? And Hadoop does not have this feature. Scalability. Both Hadoop and Spark are highly scalable and can handle large amount of data, but Spark is generally considered to be faster and more efficient for big data processing. Ease of use. Spark provides high-level API in multiple programming languages, making it easier for developers and data scientists to use compared to Hadoop and MapReduce, right? So when we conclude, so the most important bit to conclude it, Hadoop and Spark can be both used for big data processing, but Spark offers more versatility and improved performance for certain type of processing tasks, right? Now, how does Spark process data? So Spark uses resilient distributed dataset and lazy evaluation to process data efficiently, right? Since we have used here two things, RDD and lazy evaluation, the next question will be related to RDDs. So what is RDD in Spark? So RDD is called resilient distributed dataset, is a core data structure in Spark that is used to store and process large amount of data. RDDs are partitioned across nodes in Spark cluster. See, we have used Spark cluster, so might be the question related to Spark cluster will be asked later, allowing you for parallel processing of data. RDDs have following key characteristics. They are immutable. What is immutable means? Once RDDs are created, its element cannot be changed. Now the question arises, if they cannot be changed, how we process them? So every time when we hit transform RDD, new RDD is created. So you need to know about this as well. So we have covered this in a lot of videos in the past, but this is more related to interview. So let's think from that direction. RDD is partition, right? So an RDD is split into multiple partition, allowing for parallel processing of data. Lazy evaluation. RDDs are evaluated only when action is performed on them, such as counting the number of elements or aggregating the data, right? Now the last part, RDDs are resilient. So resiliency means if node fails, RDDs can be reconstructed from the partition stored on the other node, ensuring fault tolerance, right? So RDDs can be created from external data sources such as HDFS or local file system, or from existing RDDs through transformation such as map, filter, group by ID. RDDs can also be cached in memory for improved performance in iterative algorithms. In summary, RDDs are flexible and scalable data structure for big data processing in Apache Spark, allowing for parallel processing of data, lazy evaluation and fault tolerance. So what we have seen so far, that you are the person who's driving the interview. Whatever you are answering, if interviewer is good, then he will ask the follow-up question from your answer itself, right? So the next question will be, what is a difference between Spark session and Spark context? So Spark context is the entry point for Spark functionality, while Spark session is a higher level API that encapsulates Spark context and provide more feature. I have covered it in a lot of detail in my video, so go through it, but this is the interview question which people ask a lot. So can you explain the concept of lazy evaluation? We have already covered it, but lazy evaluation is a feature of Spark where transformations are not executed immediately, but only when action is performed in the RDD. See, everyone who knows Spark a bit knows about lazy evaluation. People, what I have seen when I take interview, that people know things, but they struggle to put those things into word or into technical words. So don't assume that you know everything. Just go through the questions and answers and try to have those technical words into your mind. For example, when we talk about lazy evaluation, we know lazy evaluation means it won't be executed immediately. It will be executed when action will be hit, and it will form a DAG behind the scene, all the transformation will be stored in DAG as form of nodes or something, right? So you need to know all this stuff, right? The seventh question: what is the difference between map and flat map in Spark? Map applies to a function of each element in the RDD and returns the RDD with results, while flat map applies to a function to each element and returns a new RDD that consists of concatenated results. How does Spark store data in memory? Spark store data in memory using RDD abstraction and automatically spills data to disk if memory is full. So next question will be around that. Let's see, what is Spark data frame? Spark data frame is a distributed collection of data organized into name columns. It is similar to Pandas data frame, right? How does Spark handle data partitioning? This is a great question, and people do ask it a lot, and interviewers or interviewees answer it in different way. But again, you need to know how to answer it more precise way, right? So Spark automatically partition data across multiple nodes in a cluster for parallel processing. The partitioning can be customized based on data and processing requirement. So this is your general questions, right? So when we jump to more general questions, so let's say, so what is Spark RDD and how does it differ from Hadoop MapReduce? We have already covered it. Can you explain Spark architecture and how it processes data? So basically, this is a great question here, right? So when we see, and now everyone knows what Spark architecture is, but the problem here is how to explain it in proper way. So Spark has a master worker architecture or master slave architecture, where driver program runs on the master node and distributes tasks to the worker nodes in the cluster. The processing of data takes place in the executor running on worker nodes, and results are brought back to the driver for aggregation. Spark also uses in-memory computing, where data is stored in memory instead of disk to speed up processing. So if you answer Spark architecture in this way, there are multiple things which will be the follow-up questions. What executors are, how to design or define executor, how to tell Spark the number of executors. So this all question will arise from here, right? Now the next question is, how does Spark handle data persistence and caching? So Spark provides a persistence and caching of RDDs and data frames in memory or on disk, so they can be reused across multiple stages and processing pipelines. This helps reduce the time required to recompute the same data and improves the performance, improves the application performance. Since we talk about persistence and caching here, the next question will be cache versus persist, right? So we'll cover it later, because in this particular section we're gonna be covering mainly about join. But before going to join, see, people, a good interviewer will not jump directly to join. He will first try to understand how exactly and how deep you know. So these are the general questions which a good interviewer should ask before he jumps to a deep dive into one particular topic. Next question will be, what is the difference between action and transformation? Transformations are the operation on RDD or data frame that produces a new RDD or data frame. Example of transformation include map, filter, reduce. Action are the operation that returns a value to the driver program or write data to the external storage system. Example of actions are count, collect, and save. How does Spark handle data shuffling, and what are some of the strategies for optimizing it? Data shuffling is the process of redistributing data across the nodes in a cluster to support certain operations. Spark's data shuffling can be performance bottleneck, so it's important to minimize shuffling whenever possible. Some strategies of data optimizing include reducing the number of amount of data shuffled using broadcast variables, repartitioning data wisely, and so on. So if you answer this question in proper way, these 6 plus whatever 15-16 questions, then half of the interview is cracked. So it means interviewer can deep dive to the next sections. Now this is where this interview series what the videos what I'm making will get interesting, you know. So now from now on, what I will be doing, I will be creating the deep dive advanced interview questions on each topic and try to give answers which is precise. I'm not saying this is the only way to answer those questions. People can answer them in other ways as well, but what I'm suggesting, these are suggestive answer, and use some of the words from these answers in answering the interview questions, you know. Why? Because they will keep you in track. For example, if somebody asks what a Spark is, you can talk about a Spark for hours and hours, but we don't have that much time, so you need to have those 5 or 10 points about Spark and just tell them, so that interviewer will know that okay, you know the answers. So now in the next section, what we gonna be doing, we will be covering 50 most important questions about Spark Joins. So we have covered general questions. If you guys want more general questions, do ping me in the comment, do subscribe the channel, comment, and then we will cover the next set of general question as well. But now let's cover joins. So joins is the most asked questions in a Spark interview. Not even Spark, I think before Spark, when I was working as a SQL developer, then also the joins was the most asked interview questions. So let's go through the questions quickly. We have 50 questions, so it might take time. I will be explaining some questions in between, but most of the time I will be just reading it from here, right? So what are different type of joins in Spark and how do they work? Spark supports several type of join, including inner join, outer join, left join, right join, full outer join. Each type of join returns a different combination of matching and non-matching rows from the two data sets being joined. The right choice of join depends on the desired outcome and nature of the data being processed. So I think this is great answer. And now the interviewer will ask you, okay, now tell me something about left outer join, tell me something about right outer join. So you tell the interviewer that okay, you know everything about join, the type of join, ask me anything, you know. So how does Spark handle large joins with limited memory? So this is not only for the joins, this is for general Spark as well. Spark handles large joins with limited memory by using a process called partitioning. Partitioning is the process of dividing data into smaller chunks that can be processed independently. Spark uses partitioning strategy called shuffling to redistribute data across nodes in a cluster to support join operation. By reducing the amount of data that needs to be processed in memory at one time, Spark can effectively handle large joins with limited memory. This is important, not related to joins but related to different transformation and actions. So have these concepts clear, right? What are some of the strategies for optimizing join performance? I will be covering this question again and again using different ways, so that you have this thing fit in your mind that okay, these are the most important bit which can be asked in the interview. Choosing the right so Spark, there are several strategies for optimizing join performance, including choosing the right join type based on the data and desired outcome, filtering data before join to reduce the amount of data being processed, repartitioning data to balance the data across nodes in the cluster and minimizing shuffling, use broadcast variable for small lookup tables and avoid shuffling, caching intermediate result to avoid recomputation of the data, right? How does Spark handle join operation with different type of data such as text and numerical data? So Spark supports joining data of different types including text and numerical data. The specific steps required to perform a join will depend on the data type being joined as well as the desired outcome, as we have discussed, you know, in the previous question. Spark provide a function and API for converting data from one type to another, as well as function for aggregating and summarizing data. which can be used in the conjunction of join to handle different type of data. Can you explain the difference between shuffle and non-shuffle join in Spark? So we have already covered shuffling in the last generic questions. A shuffle join is a join operation that requires data to be shuffled across nodes in the cluster to support the join operation. Non-shuffle join is also called map-side join. Is a join operation that can be performed without shuffling of the data. Map-side joins are more efficient than shuffle join because they minimize the amount of data being shuffled. However, they are only possible when the data being joined can be partitioned in a way that matches the join key. So this is important. Okay. Question number 6. How does Spark handle join operation with different join keys such as string and integer? So Spark supports join operation with different join keys including string and integer join keys. Spark provides a function for converting data from one type to another, so the data can be converted to appropriate type. It also important to ensure that join keys are correctly formatted and correctly match for the data being joined. What are the common problems that can occur during Spark join operation and how they can be addressed? I think this question asked a lot. Some common problems that can occur during the Spark join operation include incorrect formatting of join keys, incorrect partitioning of the data, excessive shuffling of data. These problems can be addressed by carefully reviewing the data and ensuring the join keys are correctly formatted, data is properly partitioned, and the amount of shuffling is minimized. How the amount of shuffling can be minimized, we will cover it later. Spark provides a variety of functions and APIs to help with these tasks, and important to be familiar with these tools to ensure successful join operation. How does Spark handles outer join operation with missing values in one or both dataset being joined? So Spark handles outer join operation by missing values by returning null or default values for the missing data. Spark provides a function for handling missing values such as coalesce function, which can be used to replace the missing values with the default values. Can you explain the difference between Spark SQL and Spark data frame join? So Spark SQL join and Spark data frame joins are two different methods of performing join operation. In Spark SQL join uses the SQL API to perform the join operation. Spark data frame using the data frame API to perform the join operation. Both methods have their own advantages and limitations. The choice depends on the specific requirements. For example, if you want more control, you can go for data frame. If you want SQL related or SQL implementation of join, go for SQL join, right? So if they ask you can you write a code for us, so this is the easiest way to write a code, right? So for example, you can define a data frame one. What's the easiest way to define a data frame? Using sequence. So you will say SEQ1 John Doe, first name, last name, second, and you will convert it to two data frame function here. ID is the first column, first name and last name. You will define a second data frame and convert it to ID and full name. And then how to join it? df1, this is df1, join df2, on which sequence ID inner type join. So this is how, and again this is just one example, but interviewer can ask you to write a code, so be ready to write small snippets of code, right? Can you explain how Spark handle joining large data sets? I think we have covered it. So Spark joins handle join operation with a large data set using process called partitioning. We have covered it, right? What is broadcast join and when it can be used? Broadcast join is a type of join operation in Spark where one of the data set being joined is broadcast to all the nodes in the cluster, and the other data set is broadcasting, and other data set is partitioned and shuffled. Broadcast join are used in Spark to optimize the performance for the small lookup tables. Can you explain the process of performing a Spark join operation with the skew data? So what is skew data? When the data with one key has more rows than the other keys, right? When performing a join operation in Spark with a skew data distribution, the data may be distributed unevenly across nodes in the cluster. This can result in one node being heavily loaded with data, leading to the poor performance and possible job failures. To address this issue, Spark provides the techniques for repartitioning of the data to balance the load across the nodes, such as using custom partitioning function and using bucketing. In Spark 3.0, we have a new feature called adaptive query execution, and if you give that hint for the skew data, it will perform the skew join automatically. Can you explain the difference between shuffle join and broadcast join? A shuffle join is and a broadcast join are two different types of joins. Shuffle join is a traditional join operation where both data sets are joined and shuffled and repartitioned to ensure the data is evenly distributed. Broadcast join, on the other end, is optimization for small data sets. We have already covered it, right? Again, how can you improve the performance of join? So, broadcast small data set, use optimized partitioning, filter data before join, cache intermediate results, use broadcast variable for lookup tables, minimize shuffling by using hash partitioner or range partitioner, right? And there are other ways which we will cover later. Can you explain the difference between Spark inner join and outer join? We know Spark inner join returns only the matching rows from both datasets being joined. Spark outer join will return all the rows from one dataset and matching rows from the other dataset. There are three types of Spark outer join operation: left outer, right outer, and full outer. Can you explain the concept of partitioning in Spark? We have already covered it. Partitioning in Spark refers to the process of dividing the data into smaller and manageable chunks called partition for processing the parallel across the cluster machines. The goal of partitioning is to achieve the data parallelism where multiple partitions can be processed in parallel and leading to the improved performance, right? How does Spark handle the missing data during a join operation? By default, Spark will not return any rows if there is missing data in a join condition. However, you can modify this behavior by using one of the Spark outer join operations such as left outer, right, or full outer. Can you explain the concept of predicate pushdown? So predicate pushdown, this is important question. Predicate pushdown refers to the optimization technique where Spark filtering conditions are pushed down to the data source rather than being applied after the data is loaded to the Spark. By performing filtering operation at the data source, Spark can reduce the amount of data being processed, leading to improved performance. Predicate pushdown is supported by many data sources in Spark, including structured data sources like Parquet, ORC, Avro, as well as unstructured like JSON and XML. Can you explain the concept of data skewness and how it can impact the join operation? We have covered it. Can you explain the difference between Spark inner join, Spark semi join? Spark inner join returns all rows of the matching data sets being joined. Spark semi join only returns the rows from one data set that have matching values in the other data set. Spark semi join is used to find the values in the one data set that match the values in another data set without returning the full join result. Can you explain the concept of skew join in Spark and how it can impact the performance? So see, why skew is coming in again and again? Because this is the most important and highly asked question in Spark interviews. So do cover it, right? Can you explain Spark cross join? So cross means Cartesian product, right? A Spark cross join, also known as Cartesian join, returns all possible combination of rows. For example, if one data set has 2 rows, other has 3 rows, the total will be 2 cross 3, that's 6 rows. Can you explain the concept of partitioning pruning in Spark and how it works? So now the important question comes. Partition pruning in Spark is an optimization technique that involves only processing the necessary partition for a specific query and join. It works by examining the filter condition and join condition in a query and determine which partition contains the necessary data and only processing those partitions. This results in significant reduction of the amount of data being processed, right? Can you explain the difference between Spark shuffle and broadcast join? I think we have covered it. Can you explain the difference between Spark reduced side join and map side join? So reduced side means the data join. So let me read it. A Spark reduced side join performs the join operation on the reduced side of the map reduce paradigm, while the Spark map side join on the map side of the map reduce. Map side joins are more efficient than reduce side as they minimize the amount of shuffle data across nodes. How Spark handles large amount of data and what are the ways to improve? We have covered it. Spark left semi join, I think we have covered it. How does Spark handle misvalue joining operation and what can you do to address it? So in a Spark join operation, missing values from one or both datasets being joined can result in missing join results. To address this, Spark, there are several operations such as outer join, replacing missing value with default value, or using custom functions. Okay, can you explain the concept of Spark bucketed join and how it can be used to improve performance? See, now if interviewer knows that, you know the stuff, he will jump one more level deep. So Spark bucketed join is very deep technical questions in Spark joins. So Spark bucketed join is a join operation that involves partitioning data into buckets based on hash value of the join key, then performing the join operation within each bucket. This results in more balanced distribution of the data, reducing the amount of shuffling between nodes and improving performance. We can cover it in more detail if you guys want to, so do comment. If you guys want interview questions related to bucket join, I'll cover it. Can you explain the difference between Spark full join and cross join? We have covered it. How can you control the number of partition in Spark join and why it's important? So the number of partition in Spark operation can be controlled using repartitioning or coalesce method available in Spark APIs. This is important because number of partition affects the performance of join operation, and as more partition can result in more parallel processing but also more data shuffling between nodes. The optimal number of partition for a join operation depends on several factors, including size of the data being joined, the available resource in the cluster. How does Spark handle join operation with multiple join condition? Some of the best practices. So this is good question. Join operation with multiple join condition in Spark can be performed using filter method in Spark API or by combining multiple join operation. When performing a join with multiple condition, it's important to consider the order of joining condition that and the data distribution of data sets, as this can have significant impact on the performance. Best practice for this type of join includes using broadcast join when possible, reordering the join condition for optimal performance, and considering use of partitioning and bucketing to minimize the data shuffling. This is good. I think this question I want to cover. What are different type of Spark join operation? When should you use? Spark supports several type of join operation: inner, outer, left, outer join, full outer join, left semi, left anti. Each type of join operation is suited for different use cases based on desired result. So for example, inner join returns only the rows of the matching values in both datasets. Left outer join returns all the rows from the left dataset and the matching value from the right dataset, right, including the rows with no matching value in the right datasets. For example, this is your left dataset and this is your right dataset, so it will return all the matching rows, right, plus all the non-matching rows from the left dataset, right. Left semi join return only the rows of the left dataset that have matching values in the right dataset. Left anti join returns the rows of the left dataset that do not have the matching value. Skew data we have covered. Shuffle join. Okay, let's cover sort merge join and shuffle hash join. So Spark sort merge join and Spark shuffle hash join are two different algorithms used to perform the join operation in Spark. Spark sort merge join works by sorting the data in each dataset based on the join condition and then merging the dataset based on the join condition. Spark shuffle hash join works by shuffling the data in each dataset and partitioning the data based on the join condition and then performing the hash based join on the partition data. The choice of which algorithm to use depends on the size of the data and distribution of the datasets, right. Broadcast join we have covered. Partition over there, this one is good. Spark partition based join and Spark bucketed join. So Spark partition based join and Spark bucketed joins are the two techniques to optimize the join operation in Spark. Spark partition join works by partitioning the data in each dataset on a join condition and distributing the data to the different nodes in the cluster, allowing the join partition to be performed in parallel. Bucketed join works by bucketing the data into smaller predefined unit based on the join condition and then performing the join operation on the bucketed data. Bucketed join can be improved. Bucketed join can improve the performance of join by reducing the amount of data shuffled. See, the bucketing means smaller chunks of data. These chunks are based on the bucket, and bucket is based on the hash. So if we are using that bucket to join the data, it means we just need to use that smaller bucket to join the data, right? How can you perform join operation in Spark RDD API? Can you write a code, right? So if they ask you to write a code, so you need to say sc, you need to say, okay, you need to ask few questions. Do we have specific or predefined RDDs? If not, create two RDDs using parallelize function, right? And then use join operation there. If they ask you to create a join operation on data frame, I have already explained you, sequence, and then 2df function, and then you need to give the structure to it. And then if there are different ways to do it. The easiest way to create or replace temp view or create a replace view, and then you can use SQL. And I have already explained on the top that you can use join directly on the data frame as well. Okay, I think this is the last question. How to improve the performance? I have already covered it, but let's read quickly. Broadcast small tables to avoid shuffles, repartition data so that join keys are evenly distributed. Use more efficient join algorithm, broadcast join, sort merge join, bucket join. Tune the Spark configuration parameters such as number of executors, cores, memory, and shuffle partition. Use Spark built-in performance profiling and optimizing tool using such as Spark UI, and a number of things are there. Caching intermediate join results, broadcast small data, reorder join keys, use repartition, use bucketed tables, use predicate position. We have covered it. This is kind of revising. This is the most important bit, right? And if they ask you, okay, how to do, you are using broadcast join again and again, have you ever done it? How to do it? So you will say, yes, I have done it. So it's very simple. So you need to say small RDD, big RDD, broadcast small RDD. How to broadcast it? sc.broadcast small RDD as map, right? I think ideally should be covered most of the things. I'm not saying these are the only questions which can be asked. There can be other questions. If you feel like that there are other questions which you want the answer from, do comment them. I will try to provide. See, again, I'm telling you, this is not the only way to answer these questions, but I will try to provide the optimal answer, and you can frame your answer across those statements, right? So one thing which I want to request you guys, everyone is watching the video, but when I'm seeing the video analytics, people are not subscribing to the channel. So I will strongly request you guys to please subscribe the channel, because this means a lot to me, right? To create these videos, it takes a lot of effort, a lot of time. So guys, please, if you guys like the video, if you guys share it to all your friends, right? Share it with everyone, subscribe it, and like the video and comment. Thanks a lot guys, really appreciate your time.